Alright, today's lesson is lesson 4-3, writing functions. You have a handout for this lesson, but you're also going to need some notebook paper toward the end. Your objectives for today are to identify independent and dependent variables, to write an equation in function notation, and to evaluate a function for given input values. A couple of terms I want you to be clear on before we move forward. Whenever we model a situation algebraically, we use variables to represent the unknown values in the situation. We talk about variables as being your math question mark. We put in an X when we don't know what the number is that's supposed to be there. We will discuss two types of variables in this lesson. So we're not just dealing with one type of variables, but we're dealing with both independent and dependent variables in this lesson. An independent variable is a variable whose value is not changed by the other variable. So no matter what, the independent variable stands alone. It is what it is. The dependent variable changes dependent upon what happens with the independent variable. So the dependent variable depends upon the independent one. Now let's look at your notes handout. Alright, your first example says a painter must measure a room before deciding how much paint to buy. The first question you need to ask is, what are the unknown values? Let's look at the statement here. It says a painter must measure a room before deciding how much paint to buy. So I'm going to underline measure a room and how much paint. These are my two unknown variables here. I need to determine which one is the dependent variable and which one is the independent variable. Does the size of the room depend on the amount of paint he buys, or does the amount of paint he buys depend on the size of the room? The room is going to be the same size no matter what. So how much paint he buys doesn't have any effect on that. So how much paint he needs depends upon the size of the room. For a bigger room, obviously he's going to need more paint. So how much paint he needs depends upon the size of the room. So my Y is my dependent variable, and the dependent variable here is the amount of paint, because it depends on the room size. The X, the independent variable. So my Y is the amount of paint, because the amount of paint depends upon the size of the room, or the room size. Make sure you have all that down. The next scenario says the height of a candle decreases D centimeters, that's a D, D centimeters for every hour it burns. So my two unknowns in this situation are the height of the candle and hours it burns. Does the height of the candle depend on how many hours it burns, or do the hours it burns depend upon the height? The height of the candle depends upon how many hours it's been burning. So the height of the candle depends on how many hours it burns. The height of the candle depends on how many hours it burns. So my dependent variable, the one that depends on the other, is the height of the candle. And the independent variable that determines my dependent variable is how many hours it burns. Make sure that you have both of those down. And we're going to look at number 3. A vet must weigh an animal before determining the amount of medication. Obviously, that's really important. A vet must weigh an animal, so that's our unknown, the weight of the animal, before determining the amount of medication. That's our other unknown. Obviously, if you were to give a small animal a dose for a large animal, that could be tragic, possibly fatal. It's important to know the weight of the animal before you give the dose of medication. So these are our two unknowns. Does the amount of medication depend upon the weight of the animal, or does the weight of the animal depend upon the amount of medication? The amount of medication should depend upon the weight of the animal. So you need to write that in. Sorry. You need to write that in. The amount of medication depends on the weight of the animal. So my dependent variable, the one that depends on the other, is the Y, and it is the amount of medication. And it depends upon my independent variable, which is the X, which is the weight of the animal. The animal's weight is not going to change depending on how much medication they give it. Let's look at number 4. It says a company charges $10 an hour to rent a chainsaw. A company charges $10 an hour to rent a chainsaw. Charges per hour. So we're going to find out how much it costs. If we wanted to find out how much it would cost to rent the chainsaw, we know how much it costs per hour, but we don't know how many hours the chainsaw is going to be used for, and we don't know what the ultimate final cost is going to be. So a company charges $10 an hour to rent a chainsaw, so the total cost depends on the number of hours. The total cost depends on the number of hours it is rented, or the length of time it is rented. So my dependent variable, the one that depends upon the other, is the total cost. And it depends on the number of hours used. The number of hours rented. Make sure that you have all that down. All right, number 5. Cameron buys P pounds of apples at 99 cents per pound. Those are some really cheap apples. Pounds of apples and the price per pound. The total cost, again, we're looking at the total cost. The total cost of the apples here is going to depend on how many pounds of apples he bought. So, the total cost depends on how many pounds he buys. Okay? The total cost depends on how many pounds he buys. So your dependent variable, again, is your Y. Your dependent variable is going to be the total cost because it depends upon your independent variable, your X, and that is how many pounds he buys. All right, so this covers our first objective. this covers our first objective, and now we're going to look at writing an equation in function notation. All right, so back to what we looked at earlier with independent and dependent variables. We're going to look at writing functions. The dependent variable is a function of the independent variable. So my dependent variable here is y, and it is a function of the independent variable x. We write this as y equals f of x. That's how we say that, f of x. If x is the independent variable and y is the dependent variable, then function notation for y is f of x, read f of x, where f names the function. So f is nothing but the name of the function. You'll hear us say this a million times. F of x, g of x, and h of x are commonly used to denote functions. It is nothing more than a name of a function when you see f of x, g of x, h of x. There are several different ways to describe the variables of a function. You have your independent variables, which are your x values, your domain, and your input. You have your y values, your dependent variable, which are your y values, your range, or your output. We write that as f of x. If you want to write this chart down, I welcome you to do that. All right, now we're going to look at number 6. Write the independent and dependent variables and write a rule in function notation for the situation. Those are our directions. We have a math tutor charges $35 per hour. So we don't know how much an hour, we know how much an hour they're going to charge. We don't know how much they're going to charge total. So we have to write a function in order to figure that out. So it says here, blank is a function of, and we're going to say, in keeping with what we've been doing with our independent and dependent variables, that the charge is a function of the number of hours. So the total charge, or the total cost, is going to be a function of the number of hours spent in tutoring. So our dependent variable, the one that depends upon the other, is the charge or the total cost. And I'm going to change charge to cost, because I think we use cost more frequently than when you use charge. Our independent is the hours. We have to define a variable. So we're going to say h. H is the number of hours. H is the number of hours. The rule is that the cost equals 35H. 35 for the number of hours. And we're going to write that as f of h equals 35H.
Can you look and see? I need a graph.
All right, so that is our function rule for that situation. Let's look at our next problem. It says a fitness center charges a $100 initiation fee plus $40 per month. So the total cost is unknown, and it is a function of how many months you're a member. So the total cost, we're going to put in the first blank, is a function of how many months. The total cost is a function of how many months. So your dependent variable is going to be the total cost. Your independent variable is the number of months. And we're going to say M is going to be our variable. We're going to say M represents the number of months. The rule in function well, the rule before we put it in function notation is going to say the total cost equals 40 months. But then we also have that $100 initiation fee, so we're going to have to say plus 100. Okay? So 40 times the number of months plus 100 because we have that initiation fee no matter what. So in function notation, we're going to say f of m, because m is our variable that we chose. F of m equals 40m plus 100. So again, my f of m over here is nothing more than a name. It's naming my function. Let's look at number 8. Make sure you have all that down before you move on. You can pause the video if you need to. Let's look at number 8. Stephen buys lettuce that costs $1.69 per pound. So, the cost is a function of the number of pounds he buys. The cost is a function of the number of pounds he buys. I abbreviated number there with NO, in case you're wondering what that is. The dependent variable is going to be the cost because it depends upon the number of pounds he buys, and the independent variable is the number of pounds. We're going to say that X is going to be our variable here, and it represents number of pounds. It represents number of pounds. The rule is that the cost equals $1.69 per pound. So in function notation, our function rule is going to be f of x, which is just the name, equals $1.69 and that's how we'll find out the cost of Stephen's lettuce. All right, the last one of these we're going to look at is going to be number 9, and it says an amusement park. Make sure you have all that down, by the way. You can pause the video if you need to. An amusement park charges $6. Charges a $6 parking fee plus $29.99 per person. So the total cost is a function of the number of people plus $6. Go back up with me. I'm sorry. I messed up there. I left that part out. On this one, number 7, the total cost is a function of how many months plus $100. I'm sorry. I left that out. So go back and fix that. You should still be on the same page, so it shouldn't be that big of a deal. Go back and fix that, and then let's come back down to number 9 and look at this. So the total cost is a function of the number of people plus $6. The number of people plus $6. My dependent variable is going to be the total cost because it depends upon how many people are going. My independent variable, again, is the number of people. And that $6 is not going to change, so that's not part of our independent. We don't include that there in our independent variable. Number of people. My variable, I'm going to say P for people. My rule is that the total cost equals $29.99 per person plus 6. So that's my rule. The total cost equals $29.99 per person plus $6. And in my function rule is going to be f of p, because p is my variable. F of p equals $29.99 p, showing that I'm multiplying it times the number of people I have, plus 6. Alright, so that's all that's going to be on your worksheet for this video, and now you're going to get out a sheet of notebook paper. Once you have all that down, you can pause the video if you need to. You're going to move over to your notebook paper now.
Alright, so we've covered the first two objectives. We should now be able to identify independent and dependent variables. We should also be able to write an equation in function notation. The last one is to evaluate a function for given input values. It says you can think of a function as an input-output machine. As you put numbers in, you're going to get different numbers out. So if we put in x, we get 5x here. If we put in 2 into our machine and we say 5 times 2, we get out 10. If we put 6 into our function, 5 times 6 is 30, so we get out 30 in our output. So just a little bit of a way to think about that. Alright, go ahead and write down number 10. It says f of x equals 3x plus 2, and we have two different parts to this one. We have a and a b. We're not picking one, we're just working both separately. Part A wants to know what function f of x is when x equals 7. So we're going to evaluate this function at x equals 7. So here, everywhere in my function I see an x, so I'm going to plug in a 7. So we're going to say f of 7 equals 3 times 7 plus 2. So everywhere I saw x in my function up here, I plugged in a 7 for it. Now this part over here is just a name. It's saying we're evaluating function f, which tells us the specific function, and we're evaluating it at 7. So this part is just a name. We're not going to do anything else with it. We're only going to work out what's on the other side using order of operations. 3 times 7 is 21. 21 plus 2 is 23. So f of 7, or the function f evaluated at 7, equals 23. Then we're going to do the same thing for negative 4. We're going to say f of negative 4 equals 3 times negative 4 plus 2. So up here, everywhere I saw x, I plugged in a negative 4. And again, this part over here is just the name. It's saying function f evaluated at negative 4 equals. So we're going to say 3 times negative 4 is negative 12. Negative 12 plus 2 is negative 10. So function f evaluated at negative 4 is equal to negative 10. Take a minute, make sure you have all that copied down before you move on. Alright, go ahead and write down number 11, and it's going to say evaluate g of t equals 1.5t minus 5 for the given input values. And for A, our input value is 6, and for B, our input value is negative 2. So again, at first, when t equals 6, I'm going to plug in everywhere I see a t, I'm going to plug in a 6. So g of 6 equals 1.5 times 6 minus 5. And again, this part here is just a name. It's saying use function g and evaluate it at 6 and see what you get. So for this one, 1.5 times 6 is going to be 9. 9 minus 5 is 4. So function g evaluated at 6 gives me 4. Here we want to know what g of t is when t is negative 2. So everywhere I see a t, I'm going to plug in a negative 2. Let me scoot that over so that it's all on the screen there. Alright, so again, this part's just the name, function g evaluated at negative 2. Then I'm going to multiply 1.5 times negative 2, and that gives me negative 3. Minus 5 gives me negative 8. So function g evaluated at negative 2 will give me negative 8. Go ahead and take a minute and make sure you have all that written down before you move on. right, go ahead and write down number 12. H of R equals 1/3 R plus 2. And part A wants us to evaluate R at 600, and part B wants us to evaluate R at -12. Alright, so again, I'm going to take my function, H of R, and I'm going to, instead of R, I'm going to plug in 600. So we're going to say H of 600 is equal to 1/3 times 600 plus 2. Don't let the fact that this one has a fraction throw you here. You have a fraction button in your calculator that you could use. 1/3 of 600 is 200, plus 2 gives me 202. So function H of R evaluated at 600 will give me 202. Now we're going to evaluate R at -12. So we're going to say H of -12 is 1/3 times -12 plus 2. And again, this part, just the name, we don't do anything with it. It's saying function H evaluated at -12. 1/3 of -12 is -4, and -4 plus 2 is -2. Let me scoot that over so you can see all that. Sorry about that. There we go. Make sure you have that all written down before you move on. So again, each time they're going to give us our function, and they're going to give us two different values to plug into that function. Alright, go ahead and write down number 13. It says H of C equals 2, C squared minus 1. Part A wants us to evaluate C when C is 1, and Part B wants us to evaluate when C is -3. Alright, so here, everywhere I see a C, I'm going to plug in a 1. Again, this part, again, remember, is just the name. It's saying function H evaluated at 1. Now here, be careful. You can't say 2 times 1 and then square it. You have to square the 1 and then multiply. Order of operations says do exponents and then do multiplication. So we're going to say 2. 1 squared is 1. 2 times 1 is 2. 2 minus 1 is 1. So function H evaluated at 1 gives me 1. Now you're going to evaluate when C is -3. So we're going to say H of -3 equals 2 times -3 squared minus 1. And again, make sure anytime you're plugging the number in that you have parentheses around it, especially if there's an exponent. Again, here, be careful. You're not going to multiply these first. You have to take the -3 and square it first. So we're going to say 2 -3 squared is 9. 2 times 9 is 18. And 18 minus 1 is 17. Go ahead and take a minute, make sure you have both of those written down before you move on. Okay, number 14, we're going to look at the function g of t equals 1/4 t plus 1, and we're going to evaluate it at -24, and we're going to evaluate it at 400. Again, just because it has a fraction, don't let that scare you. You have a fraction button in your calculator. So here, everywhere I see a t, I'm going to plug in a -24. And from here, I'm just going to follow order of operations. 1/4 of -24 is -6, plus 1 is -5. So function g evaluated at -24 will give you -5. Now we're going to evaluate at 400. G of 400 equals 1/4 times 400 plus 1. Let's get that over a little bit so you can make sure and see. 1/4 of 400 is 100, and 100 plus 1 is 101. So function g evaluated at 400 gives us 101. Take a minute, make sure you have that copied down before you move on. Alright, so that's your final objective, to evaluate a function for given input values. We do have one more example that we're going to wait till in class to do tomorrow because it's a real world example. Go ahead before you leave and go ahead and try, or before you stop the video, go ahead and try number 1 and number 2 on this before you go. Okay, so take a minute, pause the video, try number 1 and number 2, and then check back and see if you got it correct. Alright, hopefully you've paused the video and tried these. Though number 1 says a moving company charges $130 for a weekly truck rental plus $1.50 per mile. And for that one, our dependent is the cost and our independent is the number of miles, because how much we're going to pay is going to depend on how many miles we take that truck. And then our function is, I called it f of m. You could have used different variables. I used m for miles. So f of m equals 1.5 times the number of miles we're going to go plus $130. So if you got that right, good job. If not, please go back and fix it. Number 2 says f of x equals 6x minus 1. Find f of x when x is 3.5 and when x is negative 5. And you should have gotten, when it was 3.5, you should have gotten 28. When it was negative 5, you should have gotten negative 31. If you did, good job. If not, please go back and find your mistake and fix it. If you can't find your mistake, bring it with you to class tomorrow and we'll look at it together. Okay, that's the end of your video. Thank you for watching.